This is Chapter 9 Review. Number 1. The bar graph shows the number of vacant rooms at a hotel over a 5-day span. How many more rooms were vacant on Thursday and Friday than on Monday and Tuesday? Okay, look at the wording in the problem. How many more rooms were vacant on Thursday and Friday than on Monday and Tuesday? So you have to find out how many rooms were vacant on Thursday and how many rooms were vacant on Friday. So I would suggest anytime that you have a graph, a chart, a table, that you put the total on top of the bars. So if I looked here on Monday, I'm going to be guessing that that's going to be about 18. This one obviously is 15. Wednesday is obviously 25. Thursday is 30. And Friday would be about 23. So now you need to put underneath here Thursday plus Friday, and then look and put Monday plus Tuesday. Find the difference. Okay, so you're going to find the difference. So you would have Monday, Thursday total here, and Monday, Tuesday's here. And when you find the difference, you're going to subtract. Okay? So find Thursday and Friday, find Monday and Tuesday. Add those Thursday and Friday together and Monday and Tuesday together. And then you're finding the difference. Number 2, the double dot plot shows the number of hours each month 2 groups of students reported that they watched TV. Hours of TV for group 1, hours of TV for group 2. Compare the shapes, the centers, and the spreads of the 2 populations. Write an inference you can make about the 2 populations. Okay, let's just find the median for both of them. Find the center. Okay, this one is your center on this one, okay? If I drew a box around it, that would be my center, and this would be my outside of whiskers. Now find the middle of this one. So the middle here is going to be 27. That was your middle there. So just to kind of give you what they look like. Now then, as I read through these, let's cross out what is false. Compare the shapes, centers, and spreads of the 2 populations. Write an inference that you can make about the 2 populations. A, group 1 has a greater median number of hours that they watch television. Okay, so far they do. Group 1 has a larger interquartile range, so the data is more spread out. Well, the data is really not more spread out here, so that part makes it false. But since it asked about the interquartile range, let's find those real quick. Okay, so the interquartile range would be what's inside of the interquartiles. So 37 minus 33. That is your interquartile range. 28 minus 23 would equal your interquartile range for this group. But I can tell you this spread is more spread out than this. So, can't be A. Group 1 has a larger median. Median's 35 here, 27 there, so that's correct, of hours they watch television. Group 1 has a smaller interquartile range. The data is less spread out. So I know so far that's true. You have to find the ranges to finish the other one. So we want to see if it's a smaller quartile range. C, Group 1 has a greater median number of hours that they watch television. Yes. Group 1 has a smaller interquartile range and is more spread out. Well, we don't know that. We know that Group 1 is not more spread out. D, Group 2 has a greater median number of hours watched in television, 27 to 35. That's wrong. So, since I helped you answer that question, it is B. So let's finish this since I helped you out. That would be 4. This would be 5. So there's a smaller interquartile range. So yes, it's smaller. And it's less spread out. Number 3. The dot plot shows the test scores of students that what fraction of total students scored 60? Express in the simplest form. A lot of you do not reduce your fractions. So, let's see. How many scored a 50? 1, 2. How many 60? 4. 73, 83, 92. So what was the total amount of students who took this? So 4. If I added those up, I'd get 14. What fraction of total students scored a 60? So I'm looking for 60. 14 is your total. 4 is the number of students who scored 60. Reduce it down. It's not that answer. Reduce it. Number 4. Of 350,000 registered voters, 800 were randomly surveyed. Their voting preferences are listed in the table to the right. Predict how many registered voters would vote for Sanchez. Okay, so if you added all these up, it should come to 100 because it's a percent of voters. When you're talking about percents, it needs to go over 100. So if I put percents over 100, and we wanted to know how many would vote for Sanchez, it would be 45 out of 100. Okay, there's a couple of ways you can do it. I always like to set up my proportions. So if I were to do it, I would be solving for X because this is the total of voters that you have. How many of those voters would vote? That's one way you can do it. The other way is to change this one to a decimal and then multiply by it. Either way works, okay? If I change 45% to a decimal, that's what you would get. Either way works, okay? So this one would be 45 times 350,000 equals 100x. You're going to end up dividing by 100. So it's kind of what we just did. So this one or this one will work. Okay, choose which one you want to use. Number 5. Jane Lee wants to know if her neighbors want a speed limit on their street reduced. She writes every house number on a piece of paper, puts it into a bag, and selects 15 papers. After surveying these houses, she concludes that 75% of the people on her street want a speed limit reduced. Is this conclusion valid? Justify your answer. Okay, it was random. She put all of the every house on a piece of paper. She puts it into a bag, and then she selects 15 papers. I'm assuming at random. So everything seems pretty legit. And then once she selects these, she surveys those households. So I believe it's a valid because nothing really said that it was not valid. She didn't play favoritism to anything. So was it on convenience or was it based on unbiased simple random sample? So she put everything in a bag and just selected 15. She drew 15 papers out of the bag. And then she went to those houses and surveyed those houses. It wasn't convenient because it didn't say how long her street was. It was a simple random sample. So your answer is D. Number 6. Mr. Who put students' names in a hat and selected 5 names without looking. What type of sample did he form? It's kind of like the one above it. Okay, random, and it was simple random sample. Number 7. Mac randomly asked the passengers at 2 different airports how long they waited at baggage claim. The double plot shows the results. Compare their shapes, centers, and spreads. Write an inference you can make about the passengers at the 2 airports. Okay, so highlight their centers. This is airport 1, this is airport 2. So this center equals 9. This center equaled 8.5. Okay, let's see if we need to know any more. A, the waiting time at airport 1 has a median of 9 with an interquartile range of 4. Okay, so we know that the median, the center, is 9. But we didn't find the interquartile range. So this would be 11 right here to here. So here to here, 11 minus 7. It's a 4-minute wait. At airport 2, you had from here to here, which was 10 minus 8 equals a 2-minute wait. Okay, so let's look back. With a interquartile range of 4 minutes, so that was true. The waiting time at airport 2 has a median of 7. Well, we found the median, the center, to be 8.5, so that's wrong. The waiting time at airport 2 has a median of 9. So airport 2 had I put a center here, it should be median, so you don't get confused. Median was not 9. That's false. C, the waiting time at airport 2 has a median of 9 minutes, not airport 2. D, the waiting time at airport 1 has a median of 9 minutes, That's correct. With an interquartile range of 4 minutes, that's correct. The waiting time at airport 2 has a median of 8.5, that is correct, with an interquartile range of 2. In general, passengers wait more at airport 1. So by ruling out, crossing out all the false, we found the right answer. Number 8. Select an appropriate display for each situation. Justify your reasoning. The height of 7th graders arranged by intervals. So, there's your key word. Which graph is grouped by intervals? Is it A, line graph? It shows changes over a period of time. B, a circle graph. It compares parts of the data to the whole set of data. C, a histogram. It shows frequency of data divided into equal intervals. D, bar graph. It shows the number of items in specific categories. So look at C again, histograms. It says it shows frequency of data divided into equal intervals. That's what we're looking for, intervals. So that one is C. Number 9, a survey showed that 70% of students would select roller coasters as their favorite ride at an amusement park. Out of 5,000 students, predict how many would select roller coasters as their favorite ride. So again, 2 ways you can do it. I always go to my proportions. 70% chose them. Out of 5,000, how many would choose them? Okay, you can do it that way, or you can do 70% as a decimal times 5,000. I always go with my proportions because it's just something that I do on a regular basis, and that's what I feel comfortable with, to set things up as proportions. Either way will work. Number 10. A basketball coach says that the average height of his starting 5 basketball players is 72 inches. The heights of the 5 players are shown in the table. Explain how this could be misleading. Okay. Keywords average, 72 inches, and there's something misleading about it. Okay, so let's put these in order from least to greatest. 68, 68, 69, 70, 85. Okay, A. The entire team is actually shorter than 72 inches. Well, that's false because we have an 85 inch. I'm proving it wrong. 3/5 of the team is actually shorter than 72 inches. So 3 out of 5 would be shorter than 72. And that's wrong, so it would be 4 out of 5. So that's wrong. 4/5 of the team is actually shorter than 72 inches. As we just stated there, 4 out of 5. Okay, 1, 2, 3, 4 out of 5 or shorter than 72 inches. D, 4 out of 5 of the team is actually taller than 72 inches? No. So your answer is C. Number 11. A survey found that 5 out of 6 in a community visit a dentist on a regular basis. If there are 4,320 people in the community, what is a reasonable prediction for the number of people who would visit a dentist on a regular basis? So, again, I would go with 5 out of 6 equals how many out of 4,320? However, there is another way. If you turn 5/6 into a percent, you could do that too. If I change it to a percent, you would get 5 divided by 6. Okay, that turns in to 0.83. Okay, 0.83 multiplied by 4,320, you would have your answer also. Again, I prefer this, but you can do it that way. There's two different ways. Number 12, use the box plot that shows student test scores for 2 classrooms. Okay, so again, I'm looking at my medians, looking for which has a greater range of scores. Okay, so we're just looking for ranges. What is the range of room 30? Finding your range is your largest number, which would be 100, minus your lowest number, 70. Your range on room 240 would be 100, minus your lowest would be 55. Which one has the greater range? Number 13. The dot plot below shows the number of fiction books read by one 7th grade class. The teacher says the average number of books read is 6.5. Explain how this would be misleading. So she's saying average is 6.5, but something's misleading. Let's prove it. Okay, the teacher used a mean. So obviously the mean is 6.5 because they all have mean. Mean is your average. Add them together, divide by how many you have. Which is greater than the median? We need to find the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. So the median is going to fall right in the middle. So median equals 5.5. Which is greater than the median? Okay, that's true. It is greater. So if with the mean equals 6.5 and a mode of 5. Remember the mode median is no, it's 5.5. But the mode is the one most often. There's your mode. Okay, so it says the median was 5. That's wrong. The teacher used the mean of 6.5, which is greater than the median 5.5. So the median is 5.5, and the mode is 5. That one's good. The teacher used the mean of 6.5, which is greater than the median 4.5. That's wrong. And the mode is 6. Oh, that's wrong. The teacher used the median of 6.5, which is greater than the median of 4.5. Wrong. The mode of 5. This is right, but this is wrong. This is wrong. This is wrong. This is right. But the only one is going to be B. Sorry, I might have confused you on that one, but didn't mean to. 14. Select the appropriate display for each situation. Justify your reasoning. The results of a survey on students' favorite school subject. Okay, would a line graph be good? It shows changes over a period of time. Well, I hope that they won't be changing their mind over a period of time, so I would cross that one out. A circle graphic compares the parts of the data to the whole set. Maybe. C, a bar graph. It shows the number of items in specific categories. Because we are doing categories, specific categories, and the number of students. I'm going with C. 15, Antoine wants to know how often a resident in his neighborhood go to the beach. He asked 3 random households from each street on his neighborhood. Is this a sample method valid? This is a simple random sample, so the sample is not valid. Yeah, it's valid. This is a simple random sample, so the sample is valid. It's not biased. It's convenience. No. 3 random households. So I would go with B. Number 16, a survey found that 6 out of 8 students own a pet. 6 out of 8. If there are 320 students in school, what is a reasonable prediction for the number of students who own a pet? So again, you can do it this way, or you can convert this to a decimal and multiply, whichever one you prefer. Okay, I'm going to, the bell rang, so I'm going to let you do the last 4 by yourself. If you have any questions, you can ask them on Google Classroom or come in the morning for tutorials.